In this lesson, we're going to be discussing common logs. A common logarithm is simply a logarithm with a base of 10. And as far as the notation, just like square roots, the index, there's no number for the index for a square root. Likewise, whenever you have a logarithm with no base written, it is understood that that base is 10. Now, since all scientific calculators include a log function, you can use the change of base formula to evaluate non-base 10 logarithms, non-common logs. And the way that you do that, if you have a logarithm with a base other than 10, you can use the common log to do the calculate the log of what you're taking the logarithm of, divided by the log of the base. For example, you have log base 3 of 27. To use the change of base formula to evaluate this, you would take the common log of 27 divided by the common log of 3. And you would approximately calculate 1.43313 divided by 0.4771. And just by changing the form from logarithmic form to exponential form, we would be able to already determine that the value of this logarithm is actually 3. Now, like exponential equations, when logs with the same bases are equal to each other, you can then set what you're taking the log of equal to each other. For example, if log base 10, or the common log of x, equals the common log of y, that means that x equals y. So as you can see in this equation, you have two logs of base 10 set equal to each other. So you can now set what you're taking the log of equal to each other. And whenever we solve for x, we get x equals -1. To solve this logarithm, we only have one log on one side, so we would start by isolating that logarithm, dividing both sides by 5. That will give us the log of n minus 3 equals 2. And then the last step is we want to take the base of the logarithm and basically put this logarithm in exponential form by writing 10, which is the base of the logarithm, to the second power equals n minus 3. 10 squared is 100, plus 3 to isolate the n would be 103, so n equals 103. And this last example, we have two logs again set equal to each other. They both have the same base, so we can take what we're taking the log of and set that equal to each other. We have a quadratic equation. We can factor that quadratic equation, get x and x. The back end of the parentheses, we have 8 and 10. 10 should be negative, 8 should be positive. When we set those factors equal to 0, we get x equals -8 and x equals 10.